Good morning, everyone. Today is episode 1 of Motorcycle Basics, internal combustion engines. So the point of a motorcycle, like any vehicle, is to propel you forward through space. If you think about your bicycle, your body is taking mechanical energy from your legs, transferring it through the pedals to rotational force to move you forwards. In the case of any vehicle, any internal combustion vehicle, we're using the chemical energy from the fuel to translate into that movement, the kinetic energy to move the motorcycle forwards. And the way it does that is through explosions in the engine. That's what's called an internal combustion engine. Now, combustion, think of fire, explosions. If you remember from probably early high school, late elementary, you have the fire triangle. The idea behind the fire triangle is to have fire, you need 3 things. First, you need some sort of fuel. You need oxygen, because like you, fires need to breathe. And you need heat of some sort. And once you have all of those 3 things, eventually you will get flame. In the case of modern internal combustion engines, most of them are what we call a 4-stroke. The idea is there are 4 cycles which the engine goes through. Right here you have essentially a piston, a cylinder, and your explosion will be happening right here. You have your air and your fuel, which come into the cylinder. They're both ignited by the spark, and then is ejected out the exhaust. The force of that explosion pushes down on the top of the piston head, which rotates the crankshaft. This rotational force will eventually be transferred to your rear tire, in the case of a motorcycle, which will propel you forwards through space. The 4 strokes of your 4-stroke engine are intake, compression, combustion, and exhaust, right? So inside your engine, the intake, it intakes everything it needs, being the air and the fuel at a ratio, which is typically for a petrol engine, so gasoline, approximately 13.5 to 1. Compression is where the piston pushes up to make that space as small as possible. Combustion is where the spark from the spark plug ignites the air fuel mixture and then pushes back down on the piston. This is the only part of that cycle which is actually giving you any power, right? If you hear anyone talking about a power stroke, it is the 3rd one right here. This is the only time throughout the cycle where there will be force exerted on the top of the piston head, which is the energy that you are extracting from the fuel to move your vehicle forwards. Now, intake, compression, combustion, exhaust can be somewhat difficult for people to remember, so there's a very easy way to remember it. Intake, suck, combustion, well, compression, squeeze, combustion, bang, and then exhaust, blow. Another way to look at this would be the circle. So you have intake, compression, combustion, exhaust. Now it's not actually 365 degrees because your piston head will actually move up and down twice per cycle. Here, during intake, your piston will be at the bottom of its range of motion. During compression, it will move all the way to the top, so it goes from bottom to top. Combustion pushes back down again, that's where you're getting your power. And then exhaust, the piston head will move back down again to prepare itself for the next cycle. So here you actually have approximately 720 degrees of movement of your piston head. Now this is important because for every 720 degrees that your piston head rotates, you're only actually experiencing power onto your rear tire for approximately 180 of those degrees. This matters because depending on different engine layouts, you actually would be able to feel this on the motorcycle. For example, a single, which is a single cylinder inside a motorcycle, think KTM RC390, Duke 390, you have most dirt bikes will be singles as well. You will be able to feel your tire slipping and gaining traction. For the purpose of a dirt bike, this is amazing. But when it comes to street bikes or sport bikes, this is not what you want. You want a more continuous, predictable power flow. That's why most sport bikes are using what we call inline fours. So you have your 4 cylinders arranged in a line. And what this basically means is when at any given moment you have at least one piston in its power stroke, so you get continuous predictable power to your rear tire. I'll probably make another video where I go more in depth on the different engine types, but this is important to keep in mind, especially if you're looking at buying your first motorcycle. It is definitely an advantage to have, but this added complexity will come with more cost, it will come with higher maintenance, and it might not be perfect for your use case. If we look back at our zoomed in piston view, there's 2 main types of way you're going to get the air fuel mixture into the cylinder. The traditional way, which most older bikes and dirt bikes have, would be a choke, which uses a carburetor to pre-mix the air and fuel up here before it even enters into the cylinder. The way carburetor works is not super important right now, but essentially it's a manual, purely mechanical system, which means you can adjust it yourself on your motorcycle quite effectively. Due to fuel regulations, that is going the way of the dodo, and most motorcycles nowadays actually use what's called direct injection, where you have little injectors that spit the right amount of fuel for the amount of throttle. Think of your throttle as how much air you're letting into your engine directly into the cylinder. Now, this is important because it is completely done by a computer. It is more accurate. You can map your computer in many different ways, and it's better for emissions. The drawback is that's an added level of complexity, which could cause failures or issues down the line. Unless you're buying a bike pre-2015, most likely you will be direct injected, with the exception of certain dirt bikes and scooters as well. If you want to know if your bike is carbureted or if your bike is direct injected, the easiest way would probably be to look at your handlebars. Do you have something called a choke? It will be a little button on your handlebars that should look something like this. It's going to look like a funny H. What the choke essentially does is it enriches your air fuel mixture. The richness or the leanness of your air fuel mixture is essentially how much air versus how much fuel you're allowing into the engine. A rich mixture has more fuel, and a lean mixture will have more air, respectively. Typically, when you have less air, more fuel, it'll be easier to cold start your engine, which is the main use of a choke. If you're running your bike lean, for example, if you've changed your exhaust, you didn't remap your ECU, or you haven't adjusted your carburetor accordingly, and your O2 sensor is messing up your air fuel ratio, you're going to find issues like your bike might be overheating, because contrary to popular belief, even though you have less fuel, your fuel will actually cool down the heat in your engine, right? It's very important to remember that any chemical reaction is going to have multiple outputs. In the case of the engines here, we have the chemical energy, the potential energy stored within the bonds of the fuel, which will be broken down and released into heat, noise, mostly through vibration, kinetic energy, and of course the power, which will be extracted by your piston to transfer through your transmission chain to your rear tire. Oftentimes in motorcycling, you'll hear people talk about cc. cc is a unit measurement. It's a metric unit. It stands for cubic centimeters. 1,000 cc, correction, is exactly 1 liter. It is referring to the displacement of your engine. The displacement of your engine is simply the combined volume, the internal volume of all of your cylinders. So if you took your engine out, you took your block out, and you fill it with water, how much water could you fit across all cylinders within the engine? Oftentimes, people think that larger cc means more power. And For the most part, that is correct, because obviously the more fuel and air you can fit inside a cylinder during one combustion stroke, the more power you're going to make. However, it's important to note that your RPM matters a lot. Your RPM is revolutions per minute. If you're on your motorcycle, you're going to see a tachometer, probably next to your speedometer. It would either on an motorbike look something like this, with a red zone on the edge, or on a newer bike you might have an actual number, or more commonly just a digital gauge that would resemble something like this. Your RPM is how many times your engine is turning over per minute. So the more you do that, obviously the more power you're going to make. What's important to remember is horsepower and torque, even though they're oftentimes referred to as two independent variables, are directly related. All horsepower is your torque times your RPM plus a constant. That's not important to know exactly what that constant is. I believe it's approximately 5,000 and something. But that means you can either increase horsepower by increasing your torque, which is typically done through a longer stroke. So the stroke is the length of your cylinder and how far your piston moves. So obviously the farther you move, the more energy and more power you're transferring to your crankshaft, the higher your torque. You're going to feel that off the line because it's going to feel instant. It's going to feel, if you're going to feel grunty, it's going to take off on you. It's also, in terms of cars, if you're towing, it's very, very important. The bore is the length, so it's correction, the width of your cylinder. Now, the advantage of increasing width over increasing length is, yes, you don't have that torque, but the fact that you are increasing total volume of the cylinder without necessarily increasing the distance that the piston must move within it is directly advantageous towards having a higher RPM limit. That's because physics doesn't like it when you move a lot of weight back and forth incredibly quickly. Any cylinder which is exactly the same on its height and its width is what we call a square bore, or a square cylinder. They're not super common, not anymore at least, because typically motorcycle manufacturers will create a design with an intended purpose. If you look at Harley-Davidsons, cruisers, bikes that want more torque, they will be more like this. We call this a undersquare cylinder. So the idea is the pistons move slower, but they move longer, so you can't rev your engine as high, but at the same time, you gain the advantage of all that torque. Most sport bikes use what is called an over-square engine. So the idea here is that the width is actually longer than the length. This means you can rev it incredibly high. Now, if you want to increase your RPMs, but you don't necessarily want to mess with the shape of your cylinders, there is a way you can do this. If you add more cylinders, all of a sudden, you're not spinning that same weight again and again and again and again. You can effectively disperse its movement across multiple cylinders. Now, in sport bikes that want as much power as possible, they want to rev as high as possible. You're going to see a lot of over-square engines, and you're going to see a lot of inline fours. That, for example, I mentioned the single within the Duke 390. It's a long single cylinder that comes with a cost of not revving past, you can correct me in the comments if I'm wrong, I believe about 7,000, 8,000 RPM. Finally, just a little bit of advice for anyone who wants to do their own maintenance, which is something that I will always recommend, is if your engine isn't starting. Remember at the beginning, I said you need 3 things for fire, right? Heat, fuel, oxygen. If your engine isn't starting, you're missing one of those. In the case of motorcycles, obviously the fuel is your petrol. The heat will be that spark. and the oxygen is, well, the air coming from your air filter. So all of a sudden you're cranking it, it's cranking, nothing's going. You check your spark first, check your battery, make sure your battery's good, right? If your battery's bad, no spark. If your spark plugs are bad, no spark. Fuel, clogged injectors on direct injection engines, what we see most often. Looking at that, and if it's an issue with the air, well, then you look at your air filter. It might be time to change it. Air filters are cheap, you should be changing it all the time. But once you understand the fundamentals of how a motorcycle works, the hope is you don't need to go to a mechanic. You can figure most of these things out on your own in your garage. Thank you for listening. This was episode 1, internal combustion engines. See you in the next one.